Hi guys, this is Ms. Martinez, and in this video we are factoring quadratic polynomials. The objectives that you as a student want to be able to carry out are to factor a common monomial from a given polynomial, to factor trinomials, to use pattern recognition to factor special products, and to write and factor quadratic polynomials that represent real-world situations. So by the end of this lesson, before you take any mastery checks, you want to be able to do all of these objectives. So let's get started. What is factoring? Factoring is a method of expressing a polynomial as a product of polynomials. In your margin, why don't you write this? Factoring is the opposite operation of multiplying polynomials. Factoring is the opposite of multiplying polynomials. So what we did in our first lesson, when we would take two like binomials or a monomial and a binomial and we'd multiply, what we're going to learn to do is undo that process. The greatest common factor, it's often abbreviated as the GCF of a polynomial, is the product of all of the factors shared by every term of a polynomial. In your margin, why don't you write this? It is the largest number or variable that can divide into every single term. It's the largest number or variable that can divide into every single term. All right. Now, we have some terminology. Let's actually apply it. We're going to factor these two expressions. So let's start with A. And the very first thing that you want to try to do when factoring is to always look for your GCF. That is the number one step in factoring. Look for a GCF. Look for the greatest common factor. So let's look at both of these. Okay, 15 and 45. The largest number that both those have in common is 15. And the most of the variables that they have is x. Now, the most that you could pull out of both is just 1. So the GCF is 15x. And if you would factor that out, if you would divide that out, essentially dividing each term by that GCF and pulling it out, you would have 15x. And all that would remain inside would be x plus 3. So you're essentially pulling that out. You're undoing the distribution. If you wanted to check, you could multiply that 15x in, and it gives you 15x squared. And 15x times 3 gives you 45x. So we have undone the distribution. We have factored out, we have divided out, and now we have written this as a product, as 15x multiplied by x plus 3. All right, so now let's try example B here. Again, we look for the greatest common factor. So it's 2x times 3x minus 7. That's one of the products. That's one of the terms we're working with. And 5 times 3x minus 7. So when you look at those two, what do they both share? Well, they both have 3x minus 7. And so if you were to divide that out, if you were to factor that out of each, it might look something like this. and the common elements would cancel out, and you'd have a 2x and a 5, and that is what remains if you were to pull out the 3x minus 7. You would have only 2x plus 5 remaining, and so that is your second factor. All right, now a polynomial, when it is in this form, ax squared plus bx plus c, that is called a quadratic trinomial. And we can factor quadratic trinomials. These are kind of like what you saw a lot of when in that first lesson. And so we're trying to undo the foiling method. We're trying to undo distribution. So what I think a lot of you all were discovering when you were working through those jigsaw puzzles, those Tarsia jigsaw puzzles, was that, okay, well, I know that it's going to be, definitely it's going to start with x, and then it's going to be plus or minus something, and x plus or minus something. So we're trying to write them as their little binomial products right there, those factors. But what are going to be the numbers? Well, there's kind of a strategy I like to use. It's called the cross method. And so what I think of is, okay, I want something that is going to add to give me my b value, which is -4. And I want numbers that will multiply to give me -21, which is really what happens when you multiply a, which in this case is a 1, and -21. It gives you -21. That's your c value. Okay, so what multiplies to give me -21, but adds to give me -4? Well, those numbers are -7 and a +3. Those are the numbers that would complete your binomial factors. And if you checked, this is amazing. You can always check these problems, so there's no reason to get them wrong. X minus 7 and x plus 3, if you FOIL them, if you use distribution, will in fact give you x squared minus 4x minus 21. So we have done the reverse operation. We have factored that trinomial into binomial factors. Let's do another one. If you want to try on your own, you can pause the video and try to do this. First thing, we know it's going to look like two binomial factors. And it's going to be x plus or minus something and x plus or minus something. And we're going to use our cross to kind of help us figure that out. Our b value is -11, and a times c would be 24. So what is going to multiply to give us 24, but add to give us -11? Those numbers are going to be a -8 and a -3. That's how you will yield a +24 and a -11. So those are going to be the values that complete our binomial factors. Now I have something a little different here in this next example. It's different because that first coefficient, the value in front of your squared term, is not 1. In this case, it's 12. When you have this type of scenario, we have to take a slightly different approach, because it's not going to just be x plus or minus something and x plus or minus something. There's going to be values in front of your x terms in your binomials. But we start off the same, and we use the cross to try to expand. We put our b value in the bottom and our ac value in the top. But a times c in this case, the product is actually -24 because our a is 12 and our c is -2. Okay, so what multiplies to give me that but adds to give me 5? That's going to be 8 and -3. Now, we are going to place those values in place of the 5x. Now, of course, you could combine those and it goes right back to 5x, but we are going through this process. We're trying to expand the middle term using the cross so that we can carry out this next step. We're going to look at the first two terms. We're going to group them and we're going to group our second terms. And we're going to look for GCFs from each of those. From the first grouping, you could pull out a 4x, and from the second grouping, the only thing you can pull out is a -1. But look at what remains when you pull out your GCFs. You have a matching binomial there. That is going to remind you of an example, one of that first example. We can pull out, we can factor out that common binomial, and the result, if you pulled that out, would be 4x minus 1. Now we have expressed it in such a fashion that if you use distribution, it would in fact give you the original statement. All right, let's do another like this. Again, we'll use the cross to expand the middle. Our b value is 19, and our product, a times c, is going to be a -42. Now, don't get too hung up here. Just start writing factors. -1, well, 1 and 42. Okay, that's not going to give me 19. 2 and 21. Oh, you know what? That's going to work. And if I make the 2 negative, perfect. Okay, this works. So don't stress out. Just start writing your factors, okay? Even if it doesn't just pop into your head, just in those little wing areas in the sides, start writing factors until you get to what you need. Okay, so let's expand the middle, and that would be a positive 19 if you combine them, but don't combine them. What we need to do is group and pull out a GCF from each of those. Well, from the first, all you can pull is an x, and from the second, it would be a 7, and look at there. The result, the leftover part, is identical, so we can pull out that common binomial factor, and the other factor will be x plus 7. So there you have it. That's another example when your a value is something other than 1. Last one here, let's try this. Factor out the GCF. Okay, why are we taking this different approach? Look very closely here. It's x cubed and x squared, and the last one even has an x. That means you could pull an x from every single term. You always, always, always want to check for a GCF first. And look at each of those number values, -3, 15, -36. Those are divisible by 3. Our GCF, the largest thing you could pull out, is a -3x. And I would encourage you, you always want to try and make your first term positive. So by dividing out this negative, it'll be really nice. What you'll have is a -3x, and inside the result would be x squared minus 5x plus 12. Okay, now that inside portion, we want to try to factor it as well. And you can try and do that mentally, or you can try using the cross to help you out. What would go in the bottom is your b value, which is -5. And on top would be your AC value, which is going to just be 12. Okay, so what multiplies to give us 12, but adds to give us -5? Okay, 1 and 12, that doesn't work. 2 and 6, that doesn't work. 3 and 4, that doesn't work either. Are there any other factors of 12? There aren't. What does this mean? That means that the trinomial inside there, it cannot be factored. And this happens. It won't divide nice and even. So that would be what you see there at the very bottom of your screen. That would be as factored as we can go for this problem. So ladies and gentlemen, you've seen a whole variety of different factoring scenarios. If you had any questions or if anything was unclear, please make a note of it and we'll talk about it in class. Thanks. See you soon.